que en YouTube you can see how many people are watching. I think that the lights are in our face. I can barely see anything.
I guess you better go center because nobody else coming with you. So I guess you can go center.
Center?
Yeah. So you shift one seat over and you go one seat over.
Okay.
I think we're good here.
So
Don't worry about it.
You okay?
Yeah, we're good. Porque no hay más nadie.
Porque no
I know y viene. I'll-
Stay beside me. Yes, that's where I'm supposed to sit.
Is somebody else coming?
The primary, but he says he's not. Of Nevis, Mrs. Henry Lewis, lead advisor, Mr. Albert Gordon, general manager, Mr. Stedman Truss, chairman of the board of directors, representatives from CBD, IDB, and UE, members of the media, ladies and gentlemen, our guest speakers from ERN, Gabriela Morales and Ricardo Calvo. We welcome you this evening to this public consultation to discuss the Nevis Geothermal Well project, which is located in the Hamilton area behind Marina. It's a vital project, one we believe will be a game changer, one that will change the face of Nevis and with it many benefits. But before we get into the discussion, we'll call upon Dr. Stapleton to invoke God's presence. Dr. Stapleton.
Good evening. Let us pray. Most righteous, kind Heavenly Father, Creator of the universe, we thank you for this another day that you have given to us to live and to move. We thank you, dear Heavenly Father, for giving us these natural resources, such as the geothermal energy. And we thank you for giving human beings the dominion over your creation. We pray, dear Heavenly Father, that you would continue to bless this land of ours. And we thank you for the Nevis Island administration who have seen it fit to stay the course concerning the development of geothermal energy. We also thank you for the multilateral institution and regional institutions such as the CDB and the IDB and all the various agencies for collaborating with us to ensure that we are at this stage in the development of this resource. And now, dear Heavenly Father, we ask you for your blessings upon those who would be speaking and presenting tonight. We pray for wisdom, knowledge, and understanding. We pray for insight. And we pray, dear Heavenly Father, at the end of the day, that we'll be successful in achieving this important goal of converting the geothermal resources into a meaningful, natural resource for the development of Nevis. We give you thanks for what you will do, and we thank you and ask you for your blessing on this proceeding, for Christ's sake. Amen.
Amen.
Just to add that we have been joined by Mr. Graham Ryan, who is from the UE and is currently in Montserrat doing the volcanic observatory. and also Ms. Resine Basant from the Seismic Research Center, also from the University of the West Indies. So they will be answering questions regarding the seismic activity or possible or concerns that persons may raise. We'll now call upon Mr. Albert Gordon, General Manager, to give some brief remarks of the overview of the project. Mr. Gordon.
Thank you very much, Ian, and good evening, everyone. Honorable Premier, Legal Advisor, Chairman, other distinguished guests, members of the public, those joining us online. Thank you for joining us in this consultation exercise, and we look forward to your continued participation as we try to move this project forward. So I'd like to start off by saying Nevis has the best geothermal resource in the world that has not yet been developed. We can't overemphasize that. There may be few who have better resources in terms of the ability to commercially take advantage of them, but those have been developed to a large extent. So we know we have this resource from various studies and tests that have been done, and for decades now, I think we've been looking at taking advantage of this resource. I think the timing is now right, given the desire to fight climate change and the potential that these resources can bring to not just evolve the energy sector for St. Kitts and Nevis, but to also play a significant role in regional and even global transition to greener fuels and more climate-friendly economies. So as far as this project is concerned, we're looking to initiate the development of the geothermal resource. The estimated capacity that we could derive from this resource is over 1,000 megawatts. When you take that into consideration and compare that with the demand for electricity in Nevis and St. Kitts, we're talking about 10 megawatts in St. Kitts and about 30 megawatts. It's 10 megawatts in Nevis and about 30 megawatts in St. Kitts, so 40 megawatts. And so the resources far outstrip the current demand. Nonetheless, we are looking to develop the resource to the full potential for a number of reasons. There is the possibility of exporting power, firstly from Nevis to St. Kitts, and so there is an accompanying project to the geothermal development project, which is the development of high voltage transmission network linking both islands, and also providing support within each island so we can move bulk power more efficiently, more reliably, and with more resilience across the islands and within the islands. So this is the first stage of what is going to be a major transition of the energy sector, where we move from being a net importer of energy. Currently, we spend at NEVLEC, we are spending about 4 million EC dollars on diesel imports, and St. Kitts is spending about 3 times that. So with the development of this resource, we'll be able to not only avoid those imports, but become a net exporter of electricity, cheap renewable electricity, as well as what is now one of the accepted means of decarbonizing the different sectors globally, the production of green hydrogen and derivatives from green hydrogen. So we are uniquely positioned to become a net exporter and to exceed our demand in terms of production from renewable resources. Now, in order to get the project going, we have to have a number of things in place. First, we need very good technical capacity, and we have put that in place with the support of the Inter-American Development Bank and the Caribbean Development Bank. So we have a very good technical team with drilling engineers with several years' experience, geologists and other specialists in geothermal power development, working with Nevis and the project team to ensure that we evolve the project in the safest and best way possible to achieve the objectives at the best possible cost for consumers. And so that team is in place now, supporting a project management unit, which involves our technical best people from Skelec, both Skelec and NEVLEC, along with other specialists within the country. So aside from benefiting from that complement of capacity from external and internal, we will also be facilitating the development of the local capabilities so we can keep developing the resource going forward and be better able to manage the sustainability of the resource going forward. So aside from the technical capacity that we have in place, we have also sought to get the best financing for the project to ensure that the financial risks are properly managed and we are getting a cost of capital that is lowest possible so that we can translate that into lower tariffs for consumers. So in this respect, the Caribbean Development Bank with the IDB is providing what is called a contingently recoverable grant. And how this works is that if we drill the wells and the wells are not productive, then we don't have to repay those funds. If they are productive, then we take out that grant with a concessional loan. And we expect additional concessional financing for the development of the wells, but also for the financing of the power plant. So we are working towards that. And in terms of schedule, we have started the process for the procurement of a drilling engineer. We expect to have one on board by January, and we expect to start drilling before June. By June, the latest, but we are pushing to try to get the drilling started before that. The drilling will take about 4 to 5 months, and then based on the expectations for the construction of the power plant, based on discussions with different manufacturers, we think we can have a plant in place 18 months after we have signed a contract, which we hope to have in place shortly after we have completed the wells and tested them. So by 2025, we expect to have the first set of geothermal energy from the resource. Worst case, we are looking at 10 megawatts, but based on the optimization of the wells and the analysis of the resource, we think we may get substantially more than that. So based on the test, we will do 10 to 30 megawatts to meet the base load demand for St. Kitts and Nevis. And then we will look to add additional capacity for the production of green hydrogen, which will be from the electrolysis of water. We use the electricity to split the water into hydrogen and oxygen. And once you have the hydrogen, you can combine that with nitrogen from the air to get ammonia. Or you could combine with carbon dioxide, and we could create all kinds of fuels and chemicals from the resource, which we will export. So we're going to optimize the suite of projects we'll be able to derive from the resource in order to bring the best value to the country and based on market conditions. So we are on our way. It's a very exciting time for us. And we're looking forward to make the first steps, which are represented by this particular project. But in order, as we proceed, we want to ensure that we have all stakeholders, which especially the residents of Nevis, involved in the project, making inputs as you see fit, not just to assist us in mitigating any potential adverse impacts, which you'll hear all about shortly, but also to look at the potential opportunities from the resource, which include not just the cheap green electricity, but also potential direct use for the geothermal fluid once we have passed it through the power plant to produce the electricity. So there is a whole lot of potential additional benefits to the agriculture sector, tourism sector, transport, and so on. I won't get into those details because Ricardo has 45 slides. Suffice it to say that this exercise is to get the stakeholders on board. It's a beginning of an engagement process. We're going to be transparent and honest and open with the project. We're going to solicit your input every step of the way, and we're going to take your suggestions into consideration in the decision making going forward. So we thank you for joining us, and we look forward to your continued engagement with the project as we proceed. Thank you very much.
Thank you, Mr. Gordon. Such a brief overview. We now call upon Ricardo and Gabriela from Environmental Resource Management, which is ERM, and they'll present us with some slides and give us an overview of the social impact that it will have on the island of Nevis. So, Ricardo, turn it over to you.
Thank you, Ian. Good evening. We're going to talk tonight about the drilling project, which is part of a more ambitious plan into the future to then develop the 10 megawatt geothermal energy plant and eventually grow the production to 30 megawatts and be able to provide electricity not only to the entire island of Nevis, but also into St. Kitts, and into the future, even the ambition is bigger than that. Today, however, we're going to focus on the environmental and social impact assessment of the drilling of production wells, which eventually would feed the geothermal plant. And another component of this overall plan for development of the geothermal resource, which is the 66 kV underground transmission line. That will be the basic infrastructure to move the electricity that would eventually be produced by the geothermal plant to other parts of the island. Okay? If we can set up the PowerPoint, please. So, as I said, we're going to be talking about the drilling project and the transmission line. I am sure that when we get into the questions and answers, perhaps some of the questions will be about the broader geothermal development, and we will entertain those questions. We have on the line, connected to the broadcast, members of our geothermal development team, the company Geothermex. They are the true experts on geothermal aspects. I want to say as a matter of introduction that ERM, Environmental Resources Management, is an environmental and social and sustainability consultancy. We are not engineers. We don't design projects like this. We oversee projects like this, and we work with the project owner, in this case also with the project financing institutions, to help guide the project towards a level of highest performance on the environmental and social issues. So that's what we're here to work with you tonight. I understand that this presentation and this event is being broadcast through the YouTube channel and maybe Facebook. So I also want to acknowledge hopefully the many people who are watching what we're doing tonight. Over the next 30 minutes or so, 35 minutes, we're going to talk about the objectives of the environmental and social impact study that we did. We're going to describe the project very succinctly, and then we're going to talk about the impacts, right? And for the impacts, we need to understand what the conditions of the area are right now, and then what the impacts of the project on those conditions will be, what environmental and social management plans will be in place to mitigate the environmental impacts so that the residual impact is always low or negligible. And we're going to talk about a specific element of all of this, which is the grievance mechanism, which is the mechanisms by which NEVLEC will establish channels of communications with the community so that any comment, suggestion, opinion, or complaint can be filed and attended to promptly. The objective of this type of events is to be able to disclose information on a project like this in a manner that is timely and understandable, that opens the opportunity for the community to comment on it. And we will be talking about how the project is designed, what the impacts and mitigation are, and the management measures, and then we will have an entire period for questions and answers. I want to step back and give a little, really basic background on the history of this project. As you may know, the idea of developing the geothermal resource in Nevis has been discussed and pushed for years, since 2008, when some initial drilling took place. Then in 2017, an environmental impact study was done for the proposed project in the Hamilton States. Time went by and that project kind of went dormant a little bit. And then later in 2018, 2019, the Inter-American Development Bank and the Caribbean Development Bank started talking to the government of Nevis and the Federation. And also there was a scheme that was being structured on a public-private partnership arrangement to develop the project. So some work continued to be done. At that time, we, ERM, developed a supplemental impact assessment. Basically, we updated the older 2017 document that had been done by another consulting firm. And we did that. That document was published in the website of IDB and CDB, both. And then the project went dormant again. And now, more recently, we have become engaged again in a new phased approach where now what we're looking to do, what NEVLEC is going to do is focus on the drilling of production wells, which eventually will feed the plant in 2 or 3 years into the future. IDB and CDB are looking to approve the financing of this effort for the drilling and the 66 kV transmission line. And as part of their requirements, we have updated the environmental and social impact assessment, again, focusing only on the project at hand today, which is the drilling and the line. So what is the project? NEVLEC is working with the Nevis Island Administration to drill 5 geothermal wells with partial financing from IDB and CDB. That would be a first phase for this eventual construction of a 10 megawatt geothermal power plant, which eventually could be upgraded to 30 megawatts into the future. NEVLEC is also looking to construct this 66 kV transmission line, also looking to start updating the transmission infrastructure so that when the geothermal energy is available, then the transmission infrastructure is new, is built under the state-of-the-art standards. So the project is including that element as well. Kind of thinking into the future, trying to put this line underground before the plant comes into line. The wells will be in the Hamilton states, and then the red line shows the 66 kV transmission line. The entire corridor or the entire alignment of the line will be co-located with existing roads. So building the line will not imply acquiring right away or going through private property or anything like that. The line will be built underground on existing right away. The transmission line extends 18 miles in total, going south, then going north to Newcastle, and the drilling project is in the Hamilton states. For the production and of the injection wells, for the drilling, there will be 5 wells, 3 production and 2 injection wells. In the future, when this is connected to the plant, what happens is that the production wells bring the hot water from the reservoir, they run it through the system to generate electricity, and then it goes to the injection wells and is injected back into the reservoir. So that is a closed cycle. The drilling would be about 1,500 meters, 4,500, 5,000 feet deep to the reservoir. And to build this, there will be a rig that will do the actual drilling. That will be located on a well pad, and there will be the equipment that will do the drilling work. There will be generation of drilling muds and cuttings. As you're drilling down, the material that has been displaced comes out. And the whole work is scheduled to last 4 to 5 months. Okay? During this time, the rig is working continuously, because part of the idea is to do it as quickly as possible, right? So that we can just get done with it and have it get into production. The transmission line is, in a way, very mild. The work will consist of opening a trench about 3 to 4 feet wide, 6 feet deep. You put a pipe down there that would be about 5 inches. Every 4,000 feet or so, there will be a manhole. Once the pipe is underneath, you can put the cable and pull it through, right? And then as the construction train moves forward, you open the trench, put the pipe, cover it, and keep moving. It works very fast. It works in trains of construction. You can be building different segments at different moments. And what we are thinking is that any individual piece of land would be affected by the construction no more than by about 5 or 6 days. Okay? The entire corridor will be inside existing right-of-way. So during the construction, 1 lane of traffic will be affected, but with maintenance of traffic that can be managed. And the whole construction can take 9 to 12 months, perhaps, but it won't be like in the same place, right? It will be a week here, a week there, a week there, a month over there, in total, the entire line will be in place in about 9 to 12 months. The project, the drilling project and the transmission line is going to have a working force relatively small. Not that many people needed to work the drill. For the transmission line, 18 to 20 people. There may be different segments being built at the same time, so maybe there may be some different crews working at the same time. And then during the commissioning and operation of the wells, it takes 1 or 2 technicians to make sure that the well is doing the work. So the ISHA process, we had developed this document that is already published in the website for NEVLEC and also in the IDB and CDB websites. Hopefully some of you have had the opportunity to look at it. At this time, the ISHA is being reviewed by the planning office here in Nevis. CDB is also reviewing it, and they're looking to present it to their board in early December for approval of the financing. NEVLEC is in the process of doing the RFP for the contractor to do the drilling. They expect to have somebody selected by January, and hopefully the work can begin in May, June, take about 4 months, so by November, the wells may be ready underground and ready to work. The work that we have done in the ISHA has followed not only Nevis's regulatory framework, but we have also applied the international standards that are required by the Inter-American Development Bank and the Caribbean Development Bank. So this project, as it is conceived, and to be able to obtain the financing anyway, would have to be done, there is no choice, will have to be done under the highest standards of environmental and social performance internationally, okay? So with that, what we're gonna do in the next few minutes is we're gonna go through the different aspects of the environment, biological, physical, social. For each one, we're gonna quickly talk about what the current condition is, what the impacts that have been identified are, and what measures are proposed to manage those impacts to make them, at the end of the day, be no more than about minor to negligible. And with that, I'm going to invite my colleague, Gabriela Morales, who will speak about some of the elements, and then I'll come back a little later. Gabriela.
Good evening. I'm going to spend a few minutes talking about the biological environment. So as you probably saw on the image that Ricardo, my colleague, showed, the transmission line will be underground and will be constructed along the right-of-way. So there's no natural vegetation or any critical habitat in the areas where the transmission line will be built. There are no biological resources that are in danger along that line because the route is the main road, which is, there's constant traffic, so it is a disturbed environment. However, there will be some impacts during the construction, and the main ones are noise and vibrations, because there will be heavy equipment, a backhoe that will be used to dig the trench, and that will create some noise, and they will create also that's a nuisance to where the equipment will be working. However, in the area of the wells, that area is deprived of vegetation as well. And although Nevis has populations of birds. There are also reptiles. There is the area where the project will be located is not, it's disturbed already. So the impacts are not considered significant, they are minor. So there will be as well management measures for every impact that is produced in any activity, in any construction activity. There are impacts that, and management measures to take those impacts to as low as possible. There are initiatives to revegetate. There will be created a fence that could, so that the noise is muffled, and that will also be used for aesthetics, so that the wells will not be seen. And the traffic, and we're going to talk about this also related to traffic management. The NEVLEC will make sure that the speed limits are respected, and the work will be done as quickly as possible, precisely to minimize the nuisance. So, in terms of the physical environment, the air quality in Nevis, there is not a lot of information, historical information of air quality. However, the only emissions are created by the vehicles around the island, and emissions from burning fossil fuels. That is currently the main source of energy of the island. The impacts of the project related to air quality are emissions from the vehicles and the heavy equipment that will be used to dig the trench and to drill the wells. And it is common also in geothermal projects, the presence of hydrogen sulfide, and that could also impact air quality if it's not monitored. Also, during construction projects, there is common dust generation as well. However, the way that NEVLEC will manage those impacts is by sprinkling water in the construction areas to minimize the dust, and to have installed gas monitoring equipment to make sure that the concentrations are controlled and that the gas is not, there's no buildup of hydrogen sulfide. Also, as any construction project, there will be regular maintenance checks on the vehicles and on the heavy equipment that will be used, and avoid any unnecessary use of vehicles that are not needed at that moment. And related to noise, so this is one of the impacts that will be more noticeable, especially during drilling, because drilling will be 24 hours, will be 24/7. And also, there might be some traffic that could create noise as well. So those neighbors, those that are closest to the project, especially those within 10,000 feet, will be, which is around 300 meters, will be most affected by the noise. However, there are also mitigation measures for that. And the main ones are beams that could have vegetation around them, so that noise is reduced as much as possible. And also for the transmission line specifically, the idea is to have works during daylight as much as possible. So the neighbors that are closest to where the drilling will be done will receive a written notice of where the activities will occur, and also for the transmission line, as Ricardo mentioned, that will be built in segments. So the people who have businesses or live in those segments will also receive a notice of when activities will begin in that area. So,
Thank you. Let me continue for a little while. Talking about groundwater, there is a common concern about geothermal projects and drilling geothermal wells, in that there is a worry about whether the drilling will affect the aquifer that produces potable water. There are potential impacts associated with that, which are mainly potential emergencies. But in general, the situation is that the aquifers that produce potable water are much shallower than, and not connected with, the geothermal fluid layer, which is about 2,000 meters below. So there's no connection between the two, okay? So, let me get this. So the potential impacts include potential off-site sedimentation due to the clearing and grading of work areas that could affect groundwater, as well as accidental release of drilling fluids, lubricants, and other hazardous substances, which are, in general, typical impacts of many types of construction activity. Once the well is built, the well itself is triple cased, basically with concrete and other layers, to keep the water at the high temperature, to keep the water separated from whatever is happening around that well at that different depth, and also to make sure that the well is structurally strong enough that it's not going to break. So in general, the probability that the wells will produce any effects on the groundwater resources that are used for human consumption are very, very low. With this, in many types of construction, they all face some of the same situations where you have to store your fuels and lubricants and other hazardous materials in a well-contained area with secondary containment. You would have a spill prevention, control, and countermeasure plan where you have spill kits in case that something happened. You have people trained to address that type of situation that can occur. There is always the possibility that it occurs. And as I mentioned, the casing also prevents leaks from the well. One thing that is important in this case is that NEVLEC is looking to use water-based drilling muds, which, as opposed to oil-based, which are much more complicated to deal with, water-based mud is much easier to handle and to dispose of, okay? With respect to soils, the footprint of the wells is relatively small. So the soils, the surface soils will have very little footprint of impact and effect. The well itself, just goes straight down, and just after a few couple of meters, 5, 6, 7 meters, the soil, the topsoil won't be affected anymore, and then you go into the deeper substrates. Some of these characteristics is that on this project site, we don't expect to find unconsolidated soils that could lead to ground failure. The main types of soils in the area include gravelly loams and clay loams. And again, those are at the, the soils are at the very top of, close to the surface. And the drilling will go below that very quickly. To understand some of the main typical impacts, there is always the possibility of erosion. The site is rather flat, but it also is close to some steep slopes. And there can always be some erosion and accidental spills. And these type of impacts are also common to pretty much any construction work. And there are well understood common measures that are taken in any construction site to prevent and manage erosion, sedimentation, and situations like that. So there will be a erosion and sedimentation control plan. The project can reuse excavated materials for slope stabilization and small berms as necessary to prevent sedimentation from coming out of the site. All of this is typical to pretty much any type of construction project. We also looked at the potential for natural disasters, and that includes volcanic activity, hurricanes, flooding hazards, earthquake hazards. With respect to hurricanes, the project will be located, as you know, on the western side of the island, which is much less prone to be affected directly by hurricanes. So the probability or vulnerability to hurricanes on the project site is considered to be moderate to low. For the mitigation and risk assessment of this type of activities, there will be first a consideration of these natural hazards, and there will be an emergency preparedness and response plan. In case of, if something happens, then all the workers would know what to do. Evacuation routes, training, drills, and all of that is part of this plan. During the work, one of the key things that happens is that once we know what the risks are and we have the plan, then there are drills that are performed every so often so that the workers are ready to respond in case of an emergency. With that, Gabriela, you can tell us about the social environment?
Yes, of course. And also to complement what Ricardo was saying about the natural hazards, one of the expectations of international standards is incorporating the vulnerabilities of natural hazards into the project design, and that is precisely what NEVLEC is doing by building the transmission line underground, because in other places, a hurricane comes and then powers down because of overhead transmission lines. So I wanted also to stress that. So going to social impacts, we touched on this in the beginning of the presentation. There will be vehicles during and construction equipment during the construction of the transmission line, so they will use up one lane. That will create certain traffic. However, there will be also a traffic management plan. NEVLEC has identified alternative streets where they can divert traffic, so to avoid too much traffic in certain areas. And also there will be flag people diverting vehicles, and also to prevent any accidents with pedestrians. The transportation of the drilling equipment will come from Longport, and those will use the main road until they reach the site. However, that will not take more than 2 or 3 weeks. There will be a short impact there, and the marine traffic and the port capacity will not be overwhelmed by bringing supplies and that equipment. The port has the capacity to deal with that additional traffic. There will be, there's a grievance mechanism that I will talk in more detail in a few minutes, but there's always the possibility of filing a grievance or ask questions during that construction period if there are issues with the traffic or something, even though it is not anticipated to have any disruption to permanent structures or the construction will be within the right of way. There, people can still reach out to NEVLEC to ask questions and grievances, and that will be implemented throughout the project. We mentioned on yesterday's session that NEVLEC will also work with the Ministry of Public Works to oversee any damages to the roads due to the transportation of this equipment. And they will have adequate signaling to let know pedestrians and vehicles where they have to divert from main works. So in terms of aesthetics, even though it's very unlikely, the project will have a chance find procedure in case of any archaeological findings during the construction, and that is a standard measure under international standards. That will be, they will know what to do in case they find something that has cultural or archaeological value. And well, finally, we've been talking about this grievance mechanism since the beginning of the presentation. And this is one of the, this is a key stakeholder engagement tool that the project will have and will launch soon that will allow you to ask questions. You can submit queries anonymously if you choose to. And the idea of the grievance mechanism is to promote transparency during the entire project life cycle. So this will also be beyond construction. This will continue throughout operations as well. And it will be free of charge. You will be able to have more than one way to reach out, either in person or through a website, and those details will be, the mechanism, how it works is NEVLEC receives and registers the grievance or the comment. They review and analyze and investigate and then provide an answer in a reasonable amount of time, typically under 30 days, and then there's a evaluation and follow-up of the grievance, and they will disclose that so that you know how to file the grievance or the comment that you wanna file, and that's pretty much it.
I want to summarize what we have been talking about over the last 25 minutes, 30 minutes. We are focusing on the drilling project and the 66 kV underground transmission line. The project at the Hamilton Estates is localized. The rigs will be working on 2 platforms, drilling the wells. There will be normal, typical construction activities. There's going to be the traffic for a short period of time to bring the rigs and other materials needed for the construction. The workforce will be small. We're not talking about hundreds of workers coming in and out of the site. It's a small workforce. The transmission line will move in a progression along the route. Open the hole, put the pipe, close the hole. Every 5,000 meters, a manhole, and then you can pull the cable through the pipe. This project, as described, is categorized as a Category B under the definition of the Caribbean Development Bank and the Inter-American Development Bank. And the definition of a Category B project says that a Category B project is a project that has impacts that tend to be temporary, localized, well understood, and for which there are mitigation measures that are well established in the industry and can be applied to effectively attend to and mitigate the impacts and risks of the project. There is no way around it. During the drilling and during the construction and installation of the underground transmission line, there will be an element of nuisance to neighbors and to businesses along the transmission line. Typical to construction activities, there will be noise. The drilling is going to be noisy. There's no way around it. The project will apply measures to muffle that noise as much as possible, but there will be noise. There will be a couple of weeks of traffic. There will be some dust. There will be some disruption to the daily activities of businesses and residences while the transmission line is being built in front of them. But in general, these are, as I said, well understood impacts for which there are measures that can be applied to manage them to minimize that nuisance that will occur. So with that, I think we are ready to take questions.
Yep.
Right?
Yep.
And we're here to address your questions. And I don't know what the logistics is, if we have microphones for the audience. Okay, there is a microphone available there. So any questions or comments?
Yeah, just to add on what Gabriel was speaking of, NEVLEC will provide a platform for persons to air grievances, concerns, and suggestions. That will be on our website, and we'll also be placing boxes for suggestions, grievances, and the like at our corporate office in Valuemart and also at our customer service office. So we want the public to be engaged, and we'll take all suggestions and concerns, and perhaps that we place in the ESIA in the coming months. Okay? Questions? Just raise your hands, and somebody will come to you with a mic. Just step out into the passageway, and you can ask your questions.
One question that is asked often in meetings like this is what comes next. So what's going to come next is that in the process of the ISHA, of the study, the feedback that we are getting from this session the feedback that you can still provide after today through NEVLEC's website will be captured, and the draft document that is available on the website, we will give it another pass. We will address your questions and concerns. If there are some ideas that help refine a mitigation measure, we will take it. We will include it there. I also want to make the point that, and I said it before, but I want to reiterate that this study has been done under the requirements of CDB and IDB. So the management plans that we have been summarizing in this presentation are all aligned with international standards. And then when the project moves forward, the project will be monitored and supervised at 2 or 3 or 4 levels because NEVLEC will do their own supervision. They will supervise the work of the contractor. IDB and CDB will also monitor the performance of the project because it's their money, so they want to make sure that the project is done under the commitments that the project has made to obtain the financing. So the project will not be alone. It will be observed, supervised, monitored, and everybody's going to be making sure that everything is being done the way it should be, right, as we go. I see a hand over there. Although it's hard to see because it's so dark.
Good evening. I am Dr. Janice Daniel Hodge. I am an environmental consultant, and I'm just concerned about the monitoring plan with regards to mitigation, specifically looking at the potential for groundwater contamination. So who would be responsible to ensure that the mitigation measures proposed are implemented as prescribed? And there's one other question.
Yeah.
With regards to the trenching for the underground laying of the transmission cable, are there any plans to capitalize during that time to do any other underground installation of utilities? Thank you.
Let me address the first question. As I was trying to explain, the monitoring will be done on the project at different levels. The assessment of potential impacts to groundwater have suggested that those impacts are unlikely and minor. However, there are measures that will be applied to manage that possibility and minimize any potential of disruption of the groundwater. And when you say groundwater, I'm assuming that you're talking about the aquifers that provide water to the community. As I mentioned, that aquifer is very shallow, whereas these wells are going way deep at 15 to 100 meters or 2,000 meters. And the way the well is going to be encased will basically make a 0 probability that there will be any mixing of the geothermal fluid that comes up the well with the aquifer water. On the second question regarding if there is any thinking about taking advantage of the trenching to do other utility work, I'm gonna deflect.
It will be a phased project where we can fit in distribution, which is our current high voltage, 11,000 volts. We will put in the pipe work for that, but we're working primarily at the transmission. That is 66K, that is to feed around the island and to provide substations so we can feed from the north back to the east, the west. So we're breaking up the Gingerland and the Cotton Ground feeders so that we don't suffer from the low voltages that we've been suffering from in the past. But the distribution will be dealt with, but it'll be a phased project.
To add a few comments on that. First, on the groundwater contamination. That's one of the critical things which we try to ensure does not happen. So the drilling process actually takes that into account. So the drilling is done within a set of pipes. So once we'll first put what we call a conductor casing, big pipes section, and then we drill within that. Then we have what is referred to as the surface casing, which is designed to do exactly that, protect the groundwater. So that is inside the pipe. So it's a smaller pipe within the bigger pipe. It goes down below the groundwater level, and it is cemented in place on the outside. And then within that, we go again. There may be another casing intermediate, and then we go for the production casing, which is what the geothermal fluid is gonna come through. That will go all the way down to about 3,000 or more feet. And so you have you could think of it as a telescope, different sections of pipes protecting the groundwater, but preventing the geothermal resource from interacting with anything on the way up to the top of the well. So there will be multiple protections for that. And of course, protecting the groundwater is considered one of the critical things. For the cable, yes, we're getting the high voltage cable underground for resilience. Obviously, as you heard, it allows us to withstand any category hurricane. It's not going to be affected. The cables are waterproof, so there's no issue with water as well. And regarding additional uses, we are also going to later on look to put the existing medium voltage cables underground as well, so that's possible. So the entire grid can be more resilient. But the cables that we'll be laying also come with fiber optic cables in them. So we can actually have broadband capability essentially wherever we have power lines, which can assist in ensuring access to broadband, hopefully at a much lower cost and higher speeds than what we're getting now from existing providers. So there are multiple benefits in that respect. Since we'll be doing some work along the road, we would want to coordinate with the Public Works to ensure that the roads are properly or restored to better conditions, and if they planned any work on those roads, that would be coordinated. And also, if other utilities, especially the water department, want to lay some pipes, then we would want that to be done at the same time to minimize disruption to residents, but also to ensure that other utilities are also being developed as we move forward. Because the ultimate objective is for Nevis and ultimately St. Kitts and Nevis to be, for our utilities to be modernized. So there are other things coming. With the fiber, we're going to be moving to smart grid and so on. But to have modern, efficient utilities which are resilient and are sustainable in terms of their impacts on the environment. Good.
Yeah, good evening. Naki Tross here. I was following the project from about 2013. Now, Mr. Gordon addressed the communication question that I had in terms of the fiber optic. But what I could remember from going back to the drawing that you had with the 66 kV line, I see it going from the Hamilton site down to the plant and then around to Newcastle. What happens from Newcastle back to the geothermal site? I would like to know what would happen in terms of the 66 kV line going back from, going from Newcastle back into the plant. How would you account for that transmission line?
Yes, I'm just going to ask Naftali to probably put the system up. So what you have seen is the section of the line that can be categorized as category B because we want to expedite approval at the December CDB meeting. So there are other components to the transmission system, but these are considered category A for ESIA purposes. And so they will be treated in a separate assessment and separate application, which will be done immediately after we submit this one. So we intend to complete the loop from, if Naftali will get the map up, we intend to complete the loop from Hamilton to our N1 site now, which will take us to Catesby, so there'll be a loop there. And what you see goes up to the existing wind farm because we want to get that into the high voltage system so we can maximize output from that plant. And then we'll have another line coming around the eastern side of the island to create a complete loop around the island. That will be at a later phase because that's not critical to the initial components of the project, even though that part may be category B as well. But also to be included will be the submarine cables linking St. Kitts, which will be category A because there will be special environmental requirements to be met by those. So those are going to be implemented as well. So, okay, there's a nice picture. So ultimately, we'll have a fully integrated 66 kV system on both islands, which will improve the reliability, resilience, reduce losses. Our losses are somewhere about 10% now. St. Kitts, I think, is maybe about 20 because they have longer, what we call medium voltage lines. That's what we're using now. What we have are radial lines emanating from one point, the power station on each island. And if anything goes wrong anywhere along one of those lines, everybody on that particular feeder is out. With this new system, there will be redundancies and backups. So any major line can go out and we can backfeed customers. And most times customers won't even know if something goes wrong. So we're building resilience and redundancy into the system. So ultimately, that's what the system will look like. And then we'll have substations at different points on both islands where the current lines that you get your main power from, the 11 kV lines, those will be reconfigured so that, for example, rather than have all the lines leaving Prospect, you'll have some lines from Newcastle or Catesby and so on, and they'll be shorter. And we'll be able to, if something goes wrong at one station, we'll back up. So everything won't be just leaving Prospect. So that's where we're going. Very good question, because we couldn't leave it where it is, because then one of the criteria used for this is any major component of the line should go out and customers should know. So ultimately, that's where we're going. But for environmental approval and financing purposes, we are expediting this piece because we know that it is category B, so it's less rigorous in terms of the environmental impact and the management plan, and we can get that through to CDB very early. Hope that answers your question. Sorry.
Good night. Thank you very much, Eric Evelyn. First of all, I must commend NEVLEC and the consultants for organizing this consultation. I think it's very important. This is something totally new to the island of Nevis, and I think a lot of people still have a lot of unanswered questions. I had two questions, but Mr. Truss would have already asked one regarding the lines going around the island, because I noticed that the whole island was not completed, but then the question was just answered by Mr. Gordon. But the other question I had, I know that it's practically a go with regards to geothermal right now. I know the CDB will be meeting next month early, but based on what we are hearing, the project is a go. I was wondering, with the trenching that is to be done and the cables that are to be done island-wide, there is another phase of the Island Main Road rehabilitation project that is coming on stream very shortly. I was wondering whether or not any consideration could have been given to when that phase is being done, that you can simultaneously do anything with regard to trenching and running of cables. I don't know, it might be too early, ahead of the start of the drilling, but I was just wondering whether that could be considered.
We are in discussions with Surrey Paving. I think the project manager is here right now with us, so I think that is a suggestion that we have taken seriously, a consideration we've taken seriously, but it will be in collaboration with Public Works and also with Surrey Paving. So we are in discussions to put in the trenching, at least put in the pipe work, and look at putting in some of the manholes as well.
Yeah, so what Ian is saying, just to add a little bit, is wherever there is road work, major road work going on now, we would want to take advantage of that and lay the ducts from now, so we can bring the cables later on, so that when we get to that stage, we don't have to disturb the road work. So there is some work planned now, and we are in fact having discussions to get the necessary trenching and ducts done, so that we don't have to go back and disturb that part of the road network.
What is the footprint, the size of the footprint of the plant in Hamilton? Proposed, what's the footprint of that, the size of that plant? And second, the decibel levels in terms of noise level, how different it is from the normal day-to-day noise from vehicles and the surroundings in that residential area. I think there's a concern from those people. And then lastly would be, a third question would be the submerged lines that ought to be going around some 18 miles, as I've seen them graphically shown. Are there considerations lent to the previous wells that were explored prior in those areas, far-reaching areas other than Hamilton? Because if you're thinking in terms of expanding or at least adding phases to the megawatt but megawatt output of the power, it seems to me that those lines ought to be at least looking forward in terms of attaching to those sites where you may need to do some, huge drilling in terms of getting the optimum your megawatt if you're selling power. So those are my three questions.
Okay, so very quickly, the current site is at Hamilton Estates is about 9 acres, and that is enough for the first stage of the plant, for the well pads, and later on for the plant. So it's about 9 acres to start with. The Hamilton Stables, I think, is just about 1.2 acres, which will also be adequate for us to start. So one of the good things with geothermal projects, the footprint is very, very small compared to, say, solar, wind, along with other advantages. In terms of noise, yes, we will exceed the normal ambient noise. Ricardo could probably say a little bit about that.
Yes, I said in the summary at the end, there will be noise. There's no way around it. The project, though, has mitigation measures that are being planned to be implemented, including vegetation curtains to muffle the sound or the noise, a berm around the site to also kind of deflect the noise. There will be a monitoring plan to be implemented with receptors at the edge of the site and near sensitive receptors in the vicinity, be it homes or hotel infrastructure, and there will be this monitoring occurring, and as much as possible, the project will try to remain at or below the international standard. That is about, it depends on daytime and nighttime. So, but the noise will be higher than the baseline noise as it is today, because today there's any external sources of noise. And this project will generate noise. It will be managed and mitigated as much as possible to stay within, as possible, the international standards. And but during the duration of the drilling, which is going to be about 4 months or so, there will be a level of evident noise coming from the site.
On the third point, Natalie, if you could put back the map, please. Yes. So yes, very good question. Thank you for that as well. So we are building the grid for the future. So if we could get the map back up, you'll notice the current line. Zoom out to the full grid. So we will actually have a node at the current N1 site. So there will be a line passing from the entry site at Hamilton to passing by N2, which is in the middle in case we want to develop there as well, up to N1 site, and then from there down to Cades Bay and also over to the Newcastle area, if you could see there. So when the N1 project, which we also plan to develop that site later on, when that comes online, we don't need to do any additional work on the grid. We'll just plug that right into the existing system. Also, the existing wind plant will be plugged into the grid, because right now it feeds into one of the distribution lines, and so that limits how much power we can extract from it, even though it has been performing below the maximum that we would want to extract to put into our distribution line. But once you're putting it into a transmission system, then it's like a highway. You can move that power all around the country. The other thing is, aside from geothermal, we are looking at the other renewables, because we are blessed with an abundance of different types of renewables. So, for example, the wind turbine existing there's an area called Windy Hill, and we recently visited that area, and it has lived up to its name. It's the best site, probably in St. Kitts and Nevis, for wind turbines, so we're looking at that. But we're also looking at offshore wind. Based on a recent IDB study, we have more than 880 megawatts of what you call fixed offshore wind, which means it's wind turbines that you can plant in shallow water, between 10, maybe 20 meters of water. And those are now emerging as a very good technology for producing renewable. The price is trending to 5 cents, which is what we like. You can put larger turbines because you don't have to get the turbine blades inland, so you don't have that constraint. So there's a potential for offshore wind later. When that comes online, and we're looking at maybe 50 megawatts of the 880 megawatts, at least 50 megawatts by 2030, that also plugs right into the existing grid as well. So we are building the grid for the future in anticipation of other developments. Nevis has very good solar potential on the southern section of the island. Again, probably the best in the country. So we're hoping to develop some PV there, maybe 3 to 5 megawatts. We'll also plug into the grid. Finally, we're looking at the hydrogen production facility, which will be somewhere in the Long Point area near the port, so we can export ammonia or fertilizer, green products, which are now becoming very are being highly demanded now. So with the grid as well, we can actually move power around the island or across from St. Kitts if necessary into that what will be like a green industrial park for producing green fuels for export. And also with the grid we are looking at for St. Kitts, it will be easy to move power from St. Kitts to other islands such as St. Martin, which we know may be interested because of their high cost of power and maybe limited renewable resources. So we can help to decarbonize some of our sister islands. Antigua is nearby. It would be easy also to use the grid to move power there. So, and that's one of the reasons we're going 66 rather than say 33, because we'll be able to move bulk power more efficiently and with less losses. So the grid that we're laying out is designed to allow for integration of renewables. Also, with distributed renewables, which will be part of the solution going forward, such as rooftop PV and so on, that could also be easily plugged into the grid. And we can, where you can produce it cheaper, you move it from that area to where it may cost more. So the entire country becomes a hub for renewable electricity and what we call green molecules, which would be the hydrogen and so on to export. And in terms of the demand for green hydrogen, it's going to be very huge. The supply is not anywhere near demand. Ammonia right now, the annual consumption is about 200 million tons. That is mainly from petroleum. That has to change to green ammonia, meaning rather than using methane as a source of hydrogen, we're going to be producing green hydrogen mostly. There's also the possibility of carbon capture, but that's more expensive and not necessarily as green as we'd want to be. So essentially, we are positioning the infrastructure to support the transition to 100% renewable, decarbonizing the economy, electric vehicle charging, all of that stuff, and also for exporting green electricity and green molecules.
Good evening, everyone. Just a quick question. During some previous exploratory exercises, 2 other wells, as far as I know, were dug. What is the status with those wells, and would those be factored in any future undertakings?
Yeah. So those were test wells, so they are not suitable for producing electricity, but they were useful in demonstrating the extent of the resource. We don't have a lot of details on the wells that were dug in 2008. But we do have some information on temperature and permeability, which confirmed the attractiveness of the resource and indicated that the resource is essentially a huge reservoir beneath the western half of Nevis. So those were useful then, and they indicate the resource, but they can't be used for production. They were small test wells. The wells we're going to be doing now for production purposes will be much, much bigger. But what those wells indicate that those sites are, lines along those sites are viable. The resource is warmer closer to the peak because the heating source is somewhere, 6 to 10 kilometers below Nevis Peak. So what happens is seawater infiltrates at that level, then comes up and goes west. So that's why we see all those manifestations on the western side of the island. So the idea is to get the production wells as close to the mountain as possible because the water cools as it flows west, so we can maximize the heating from it, and so we can produce more electricity more efficiently. So those wells have served their purposes. Because of the date, they have been corroded and so on, so we may need to plug and what we call plug and abandon, which is to kill them, get rid of them, pour cement down there. But to the extent that for a while they can act as monitors, that will also be useful, because as we extract energy from the resource, we're going to be carefully monitoring it and modeling it, ensuring that we are doing it in a sustainable manner. So they will also serve as monitors in the first instance, but because of age and corrosion, we may have to, do some, abandon them and probably drill new monitoring wells later on.
Is there a need for substations? Because I know you're saying it's Nevis is relatively near, close to each other. But when you say St. Martin, it's still relatively close. Because if you were to look at how it's done, let's say in Europe, between, let's say, Iceland and Britain and Norway, you're talking about 1,000 miles plus. So in our case, because that would drive the cost up, in our case, would you necessarily need to have substation in our case to export to Antigua, such as you're suggesting, St. Martin? I would imagine not St. Kitts, because you're using 66 cables, which are huge. But, so, I mean.
Yes, you'll need substation, because what happens is we'll generate the power up at maybe 11. We'll use a transformer to step it up to 66. That is good for moving it around, but once you reach the load centers, you want to step it down first to the 11 kV that we now have, so we'll have a substation for that. And then those 11 kV will serve the demand centers at different points. And of course, you'll have the pole-mounted transformers to take it to the distribution, to the secondary voltage, 220, 4, whatever voltage we are moving, transitioning to 110, so that will come later on. And so we'll need substations at strategic points. So we have identified locations on both islands, Naftali's not showing them, where we propose to have substations. So for example, we already have a station at Prospect. On Nevis, we'll have one in Charlestown. So there's a center there. And then hopefully we'll take those 11 kV lines on the ground as well. So, the customers are protected regardless of hurricane. And we'll have one at Cades Bay, probably one Newcastle, where you have the demand centers, and also on the eastern side, depending on what's happening, we'll have substations to take the high voltage down to the usable voltage for consumers.
Just to allay the fears that some persons may have, you mentioned it earlier, but what is the connection between the potential for earthquakes associated with geothermal?
If I may take that. The seismic activity associated with volcanoes typically is connected to the layer where the magma sits, magma that eventually comes out of the volcano as lava. The depth at which the magma sits is much deeper than the depth of the water that is used in geothermal projects. So the drilling down to that geothermal resource level is much shallower than the magma underneath. There is no connection between the two, and in general, there is no connection with respect to possibilities of seismic activity. Mm-hmm. And we may have comments from our experts on that topic.
To Ryan?
From the UWI Seismic Research Unit.
Good evening, Dr. Ben Ryan from the University of Western Seismic Research Centre, also the director of the Monstrat Volcano Observatory, and been involved with the geothermal projects on Monstrat and research into that geothermal system. So So there are two aspects. One thing that was spoken about just now is the possibility of the drilling impacting the magmatic system and say trigger an eruption, and that's something that doesn't happen for the reasons that we just stated. The magmatic system is a lot deeper than you drilling, so the drilling is quite superficial compared to that. In terms of other seismic activity, it can be very small low-managing seismic activity associated with exploited wells to changing pressure in subsurface, but that's generally very low magnitude, you don't feel it. So it's generally not a problem. One thing that can be done is you install seismic monitoring, so you just kind of monitor it and make sure that there aren't any issues. But where people may have heard about seismic activity associated with geothermal systems or geothermal exploitation, this is a completely different kind of exploitation. Something that's called enhanced geothermal, where you're actually trying to create fractures artificially by pumping down water to high pressure to fracture the rock, and there you're intentionally making earthquakes, and so unsurprisingly generate seismicity. But my sense, this project is not that, it's conventional geothermal using the naturally occurring fractures. And so we would not expect to see large-scale seismicity associated with that. Although when the wells are flowing into what we see some very small earthquakes, it's actually beneficial to use them to better understand the reservoir and plan out where you're going to drill more wells in the future. So I hope that addresses your question.
Thank you, Dr. Ryan.
Good night again. Once there is smooth execution of the project, and bearing in mind there could be some unforeseen delays, which we have with a lot of projects, and with a project of this magnitude, there could be some unforeseen delays. But based on the timelines that you have, when can we realistically expect geothermal power?
All right.
Nevis?
Okay, so, sorry? Yes, so in terms of where we are now, we are hoping to get the funding approved by CDB in December. We are hoping to select the drilling contractor by January, and we're hoping to start drilling latest June, preferably May, but latest June. It's how fast they can mobilize the rig, so that would be the challenge, and which depends on where the rig is coming from. As we said, 4 to 5 months will be finished, so we expect drilling to be finished by the end of next year. While drilling is going on, once we have drilled the first 2 wells, we'll have some idea as to how much power the wells will be able to support, the 5 wells. And so we'll initiate the procurement process for the plant by whatever mechanism we're going to use. And we are hoping to have a contract signed for that not too long after the wells are completed. And then the construction time for the plant is about 18 months. It could be 14 to 18 months. So short answer to your question is therefore mid-2025 is when we are looking to get the first bit of electricity from the geothermal plant. Yeah.
Hey, good evening.
Good evening.
This is a question for NEVLEC. With geothermal and stream to come 2025, so we will be encouraging persons to use electricity, I hope, because it would be the cheapest form of power. What plans the NEVLEC has to change, how must I call it, the power distribution in Nevis? Because in some cases you cannot maximize the use of, let's say, heavy equipment, i.e. a dryer, stoves, because of the current 220 that we have. So there's a plan in place for that? If so, what is the plan?
So yes, so the first stage, as you notice, we'll be introducing high voltage system, and as somebody asked earlier, substations. So we'll have substations closer to the demand centers, and so we'll have shorter, what we call feeders, the 11 kV lines, and we'll also have backup to those lines because they can now emanate from different points, not all of them from Prospect, as is the case now. So that means you'll be able to get more reliable supply and more stable voltage, and we'll be able to also meet your demand requirements. So if you put heavy demand on the system, we have a highway to move bulk power very quickly to the substation, and from the substation it will be easy to supply that demand. What may be needed if your demand is going to be really high is you could take it at a higher voltage, and that works better for you. In terms of the secondary voltage, and we know there are some challenges with whether a lot of people want 110, but there are some complications with the transformers. Ian could speak to it. We are working out a plan to rationalize that, to make sure we are providing the modern voltage levels that are desired. There are some issues with the need for rewiring some residences, but we're trying to work with people to get that done. But we know there is that need for some changes at the what I call the secondary level voltage. So we're working to address that as well. But based on the system we're putting in place, and we're also putting in what we call SCADA, monitoring systems, smart reclosers, and so on, to modernize the system, make it more responsive. We'll be better able to supply exactly what you need. And that's one of the objectives, because ultimately it is a service that is delivered to the consumer at the meter that is important, and we want to keep that stable, reliable, and good quality.
So would it be 5 wells? 5 wells, as you mentioned, 5 turbines, or and what's the megawatts per turbine?
Mm-hmm. So it's 5 wells, 3 production, 2 re-injection. So at worst case, if those wells are not productive, which would be a major shocker based on the information we have, we'll get 10 megawatts, which you have heard about, which would convert to electricity using 5 megawatt turbines. So we have decided we're going to keep the unit sizes to 5 megawatts. If we get the 30 megawatts, we'll still stick to the 5 megawatt turbines to start with, which give you flexibility, allow you to maintain a unit while the others are running. We could go bigger, 10, 15, but then if something happens to one, then it causes a big shock on the system. Along with the turbines, we also plan to put in battery energy storage system to complement the other smart initiatives. And we are getting support from CDB again on this. We actually have a consultant doing the designs for the first 5 megawatts. And what that would mean is if a generator trips, suddenly the battery keeps the system up until we can bring up backup capacity as necessary. So, we're not going to make the units too large, even though the wells, one particular well may be able, based on the sizes we're looking at now, it may be possible to get as much as 15 megawatts from a well, but we're not going to count that until we see it. We may be conservatively getting 30 megawatts per well, but we're going to keep the unit size to 5 megawatts based on our current demand. So one unit doesn't have a significant impact on the reliability of the system if that unit should trip. And in the electricity business, you always have to plan for something to go wrong. Even though these plants will be very reliable, you have to allow for that.
Okay. Hi, good evening. This is Dylan Webb. Well done as well to NEVLEC and IDB and CDB for putting this together. It's very informative. My question is very basic, and I'm pretty sure every Nevision probably has this question on their mind. Given we know that market conditions can change, but what would be the change in the cost of the electricity to the consumer by the time geothermal is implemented? What's the change that we can foresee or forecast now?
Okay, so between now and 2025, we will have some challenges, both Nevis and St. Kitts. St. Kitts is having some problems now because both systems have old units. We have a few more modern units, but not enough to meet the demand and provide a comfortable reserve, which is necessary to maintain supply. So one of the things we have done at NEVLEC is we have brought back some older units from retirement. We have done work on some of the older units to modernize them, to allow us to keep them going and make them more efficient for another few years. But those will have to be ultimately retired. Now, the main driver of the cost of electricity now is fuel, which is diesel, the most expensive fuel that can be used to generate electricity. But that's what we have. And so we need to transition away from that. Now, with currently, the fuel surcharge in NEVLEC has been removed, thanks to the Honorable Premier, from the bills of domestic customers. And for commercial customers, we have capped it at 65, even though based on the current cost of fuel, it would be over 70 EC cents. So we are keeping the rates steady in that respect. But it's at a cost to the government. St. Kitts also has similar challenges. I mentioned earlier our fuel bill is about $4 million per month, so we're not recovering the full amount. In St. Kitts, the last number I heard was $14 million per month, and the government is picking up maybe $10 million of that. So we want to save the government those expenses and also be able to still do some reductions, further reductions on the customer bills once the geothermal is here. But between now and 2025, we'll still have these challenges to deal with, but I'm happy to say the government has been mitigating that challenge.
Good evening. My name is Sidney Newton, and I have a simple question in relation to sustainability. Excellent presentation, by the way. Considering the enormous investment in infrastructure, plants and lines and so on, what is the single most important factor that could impact sustainability of this project? Single most important concern that you might have that could impact the sustainability of this project? Or should we be worried about it failing somewhere along the line or not?
Yeah, so I'll let Ricardo speak for a while, maybe on, based on his vast experience, and I'll back up.
Let me ask a question. When you say sustainability, are you speaking about environmental and social sustainability, or the economic sustainability of the project?
Longevity.
Longevity. That's a technical question, I would say.
All right. So one of the things we're doing with the well, let me start with the easier one. The grid. It's underground systems will go 40 years before you need to make changes and so on. So that's good. Overhead lines, usually you get a good 30 years. So in terms of longevity, that's the case. But of course, you have to do your maintenance and rehabilitation and upgrade as you go along. For the geothermal project, one of the things we're doing is making sure the contractor we select is technically of the highest level. So we're not just going for the cheapest contractor. And that is necessary because the upfront cost is one thing, but the life cycle cost over the life of the project is also important. We don't want these wells to fail anytime after we have done them at all. And so if geothermal wells are done properly, they'll give you easily more than 30 years. But we have, and Ricardo, you could probably speak to that. We have heard of geothermal wells going much, much longer than that. There's a possibility of degradation, meaning you might not get the full capacity, but we can rework them to restore that. But essentially, if well managed, they can last a very, very long time. And if designed and built properly, probably 100 years, I think. So very, very possible to have a long lifetime from these wells.
Yeah, I would say the longevity is more affected by the engineering and the ability to have a plant that will be updated and improved and maintained. The resource is there, and it will be there for the duration. So it's not the longevity is not limited by the resource; it's limited by the engineering. But with a well-defined, designed, and constructed project, and then maintained, a production well should feed a plant for a long, long time.
And that's one of the reasons for the reinjection as well. So we bring out the fluid, we extract the energy, and we reinject it so the reservoir pressure is maintained. So and that water gets hot again and comes back up. So it's a cycle. So we're not pulling from the well and depleting the resource as such. So that will also help, and we're managing that very carefully because you have to, while maintaining pressure, you also have to make sure the cold water doesn't get too close to where your production wells are, so it doesn't cool that. So it's a balancing and modeling exercise that will be ongoing as we develop the resource. So the management of the resource is going to be a critical aspect of the project going forward as well. Or we ensure that the resource remains sustainable over the very, very long term.
So I'll just shift gears a little bit. This is an environment and social impact assessment with regards to, outside of NEVLEC, the availability of jobs for locals during the construction as well as the operational phase. Can you give some information regarding that, please?
From the supplemental environmental and social impact study that we have prepared, the understanding and then the recommendation as well is that labor force should be local. I understand that the commitment is that that will be the case. There may be some technical positions, management positions that perhaps, depending on the contractor, may come from somewhere where they can bring that expertise to the island. But the workers on the construction site, eventually into the plant, and certainly for the transmission line, will be local. We also have recommendations and provisions aligned with the international standards that CDB and IDB require around ensuring and promoting equity around gender, provide opportunities for women to work and establish some goals around that. So the project will have a labor recruiting plan that will focus on local force. And sorry, the number? Yeah, we showed a slide that included the number of workers anticipated for the construction of the transmission line and then the drilling of the wells. In reality, those two projects, those two elements, do not require many workers. We're talking about 20, 30 for the drilling and crews of about 9 each for the transmission line. The construction, eventual construction of the plant would require a higher number of workers, perhaps in the vicinity of 100, 150, depending. So we show that, and it's also represented in the document if you get to see it. But I guess to manage the expectation, neither the drilling nor the transmission line are projects that require hundreds of workers.
So one of the things we're doing is maximizing the use of local labor and expertise. So whatever can be done locally. So for example, a lot of the civil works, we're going to work with local contractors. So for example, the road, we're going to be building a new concrete road to the site. And we're working with Public Works. They already have a design and costing and so on. So we're going to make sure that is done locally. The trenching for the submarine, for the underground cables, that can be done locally as well. And in fact, one of the things we're doing, even though we're bringing in international experts, so for example, for the drilling, we have what is called a drilling management team with very experienced drilling engineers, geologists, reservoir, resource modeling experts, and so on. And they will be essentially guiding and making sure the project is done. It's the first time we're doing it. But we have created a project management unit and a parallel team to learn from that. So for example, even for Ricardo and Gabriela, we have employed local environmentalists to work with them for two reasons: to assist with the provision of the local knowledge, but also to benefit from their international experience. So a key part of the project will be to build local capacity and create local employment as much as possible. So we're trying to do that. The other thing is there'll be a lot of possible spin-offs, and part of the engagement is to see how we can get the local companies and persons to take advantage of those possibilities and to work with them to have to develop potential revenue earners around the project where possible. So we plan to do that, but we also want to create the work for the future. So it would be people involved in climate-friendly, smart, modern technologies going forward. So as much as possible, and if there are ideas, we welcome them, additional ideas. We've gotten one from a colleague about mining lithium from the brine before we re-inject it. Lithium is, in demand for lithium-ion batteries. So that is a possible spin-off. And if we get into hydrogen and ammonia, well, ammonia can do many things. So there are all kinds of spin-offs. There's fertilizer, agriculture, greenhouse, crop drying with the heat. There are endless possibilities. But we work with you, and we'll keep the consultation to maximize the value to the country.
My question is, in terms of the project itself, I understand it's a phased project, but could you break it down in terms of cost from the first phase, say up to 30 megawatts first, please?
Mm-hmm. Okay, so the drilling, 5 wells we expect will be somewhere around $30 million US. The power plant, if it's 30 megawatts, just going up the scale there, that's going to be somewhere 60, 70 million. And then depending on how we roll out the transmission, this first stage of 30 kilometers, the estimated cost is about $0.7 million per kilometer. Depending on how far we want to go with the grid, we could be talking about $50 million or so. But for the first stage that we're looking at here, it's probably going to be, less than 30 million, just over $20 million. So all US, sorry, yes. Well, we're talking to the CDB, so we're speaking US because that's the form in which the funds are being accessed. So if you look at that, say 30 or so million for the wells, about 70 for the plant, so that will be about 100 million based on our estimates. And for the grid, would say probably another 50. So this first stage, we're looking at about 150 million US.
Greetings. And with that comment, it makes me wonder exactly what kind of costs will be passed on to the consumers. But for me directly, I really want to know, as an individual, what benefits can I see? Are there benefits that the individual man can point out and say, okay, I can see how I can benefit? We understand a lot as the way the country is going to benefit and so on. And again, I'm hearing NEVLEC. Is this something that's going to be owned by NEVLEC? What involvement in terms of foreign companies? Are we looking to the future where things like these, this whole project, would have a high level of national ownership as opposed to foreign ownership? So basically, how can I benefit?
Mm-hmm. So the first benefit would be your electricity bill. So right now, the non-fuel part of the NEVLEC bill, I think, is about 18 US cents. If we put the fuel portion on, we're going to be, close to 40 cents. So there's that burden now being borne by the government for domestic and partially for commercial. We have a financial model for the project, and based on the modeling, most of the costs associated with the geothermal project is really the upfront capital, because the O&M is fairly low once the plant is built. We're talking maybe 3 cents per kilowatt hour, 2 to 3 cents per kilowatt hour. So the capital cost is the major cost, and then it depends on your cost of capital. So if we have funds that come with high interest rate or high return on equity, then the cost will be higher. Based on our modeling for the 30 megawatts, we think we'll be in the single digit, I don't want to say how low, but we are pushing to get really low in terms of the production cost from the facility. With that and allowing for, the admin and transmission and so on, we could be in the mid-teens. We are trying to be below the non-fuel as much as possible, so we can deliver power to customers consistently, everybody in the teens. But that requires getting the best financing terms. In terms of ownership, that's something we'll have to work with the government and the banks, because it's possible to, we're trying to get the best financing, which means either grant, if that's possible. One of the things we've been told is St. Kitts and Nevis is upper income country, so we can't get grants so easily, but there are some windows there. So for example, all the technical work that's being done is being funded with grant, but to get actual grant into the project is a little more difficult, but we can get concessional loans from climate funds because of the nature of the project. So depending on that, we can get the price lower, and but we are based on basic modeling, we expect to be in single digit in terms of production, which would allow us to sell to consumers in the teens, which would be significant compared to your bill if we include the fuel surcharge as well. So that's the first benefit. Green environment, more sustainable, less emissions, more reliable supply, better quality supply, the possibility of spin-offs, as I said, the possibility of employment during construction, directly and indirectly, and also during the operation. So as we transition, we think there'll be a wide range of opportunities, which we would want you to take advantage of.
On the heels of the gentleman's question, two questions though. Before I go there, the risking part of it, of the operation, the wells and sorts. I'm hoping, I don't know, by international standards there are the risking guidelines, and I don't know if you have employed a monitoring company that goes along with you for oversight. Their standards, meaning the integrity of the wells, and in terms of how long they'll last, because your structural integrity and all that sort of thing, because those have been established in terms of the overall de-risking. Mm-hmm. And next is in regards to the gentleman's question, which is a concern to citizens. People are looking for opportunities to invest. And even if you were to go on the international market, such as what you are doing in terms of acquiring monies, there should be a path that ordinary people can invest. You have a captive market already on the ground that is going to be using electricity, and it's going to be flourishing, not just from electrical production, but also from the investment side of it, whether you're selling fertilizers, as you mentioned, or whether you're going into concrete production, which comes up from that also. And all the other ancillaries that comes through that, and even as far as data centers. I do believe that some sort of special vehicle can be created, even if you've accessed the funds international, or wherever you're on banks or whatever, that people can invest or buy bonds into it. And that should be something, I think, that should be at least looked at in terms of the preservation of people's future in terms of wealth creation. So I just don't want you to look at the surface of geothermal and yes, we're happy we have geothermal. It's a matter of enhancing people's position in the country. Mm-hmm. And I think that's where his question is going. And I do know of an idea in terms of enhancing that and in terms of people being able to invest in it. There's an idea that's out here. but I'm hoping that you solicit some of these ideas and reach out so that they can come forward and at least advance them. People's power sort of thing.
Well, thank you for that. And it's a good idea, and I think it should be taken on board. There is an example in Jamaica, the Wig Farm, but started the renewable initiatives there, and it was government owned. I think they went up to 60 megawatts of wind turbine on 3 different projects. And what the government did was to essentially divest all the shares to the public, with no one able to own more than 10%. So I think at some point it may be possible, beyond my pay grade, for persons, Honorable Premier may speak, to regular people to invest. So if you please pass the mic to Honorable Premier.
I was hopeful all night not to have to say anything, but I think the question perhaps is a little beyond the scope of this consultation, insofar as this consultation is dealing with a specific aspect. But clearly the economics of this, and I think the language used, empowering our people, is going to be important. The truth is the model that we might use is not yet finalized, but I think that the reality is, Mr. Herbert, that when NEVLEC was put together, the ultimate goal was always to have public participation in NEVLEC. And currently, as an entity, it is 100% owned by the government. I think what we are seeking ultimately to do is to get NEVLEC in a position where it becomes attractive for investors and for investment. And I think once that is there, then we can proceed to make that necessary offer, if you will, to members of the public to come in and participate as investors. So I don't see it at this point, while we try to come up with the right model, I don't see it as necessarily an investment in the geothermal per se, but rather an investment in the utility company that would then allow our people to extract dividends from that and to be empowered in that way. But I am speaking simply on the basis of what we have imagined thus far, whilst appreciating that there could be other ideas and other models that will allow for some public participation. The truth is that the funds involved here are quite large for our size of population. The investment is quite significant, and as a consequence, we have to go outside to look for funding at this point. It also helps, as we have heard, that because of climate change issues and because right now that is the drumbeat internationally, that there is free or cheap money available to us, and that is why we have gone the CDB-IDB route to try and access some of that funding, which we hope can be grant, but if not grant, then concessionary loans at very good rates. As we have heard, all of that factors into the ultimate cost. And so far as the government is concerned, I think it has been said very eloquently. We want to achieve, of course, energy security. We want to wean ourselves completely off fossil fuels for the generation of electricity. We want cheaper electricity, more reliable supply, and we want the spin-offs that we can get in terms of the ancillary industries. You mentioned data centers, but also, of course, we've heard about ammonia, fertilizer production, we've heard about hydrogen, and a number of possibilities there that we can exploit. If done properly, and I think this is a promise of geothermal, if done properly, I think we have the capacity to completely reshape Nevis and potentially the Federation, to wean us off the dependence that we currently have on tourism, and to allow us to have a real diversification in the local economy. It also, I think, allows us bragging rights of declaring ourselves the greenest place on planet Earth. And that is something which, to me, is important for us to set the standard and to set the bar internationally for what can be done in terms of sustainability and renewable energy. So I perhaps have gone on a bit more than I needed to, Mr. Herbert, but the truth is that the model is being worked on. We will have consultations on that model, but one immediate option is to have shares in NEVLEC being made available to the general public. And we see that elsewhere. For example, Select and all of those are, I think, traded on the Eastern Caribbean Stock Exchange. So there will be opportunity for participation as we go in relation to this. But I think the people of Nevis can be assured at this point that NEVLEC is 100% owned by the government and by extension, therefore 100% owned by the people of Nevis.
I think Minister Nine now. I think we could close off. I think we're all tired now. I want to give a round of applause to the head table. Before we ask Ms. Thibault to give the vote of thanks, even though we're finishing our session now, I think we have over 70 persons, I believe, on YouTube. We are still open for concerns via the website. Those who are on island, as I said, you can pass by our customer service office in town or by the corporate office at Value Mart. And we're here to listen to your concerns. That's what it's all about. It's a nation project. And so we embrace your concerns and grievances. Thank you again for coming. We'll ask Ms. Thibault now to give the vote of thanks.
A pleasant evening, everyone. My role tonight is simple yet significant. It is to express thanks to everyone who played a critical role in ensuring that tonight's consultation was a success. I would first like to thank the Almighty God for blessing us with health, strength, and wisdom. While thanking God, I must express thanks to Dr. Ernie Stapleton for invoking God's presence. Profound thanks to the members of the head table, General Manager of the Nevis Electric Company Limited, Mr. Albert Gordon, Dr. Ricardo Calvo, and Gabriela Morales of ERM for sharing their expertise with all of us here tonight. Special thanks to Dr. Ryan for joining us remotely. Thank you to NEPAC for allowing us to use their facilities. Special thanks to Mr. Ian Ward, Chief Engineer of the Nevis Electric Company Limited, for moderating tonight's session. To the technical team, thank you for ensuring quality sound and projection. Thank you to NTV for carrying the consultation live and taking us into the homes of those who could not be here physically. To the Caribbean Development Bank, CDB, and the Inter-American Development Bank, IDB, thank you for your generosity in funding these consultations. To the Board of Directors, management, and staff, and specifically the Geothermal Project Management Unit at the Nevis Electric Company Limited, thank you for your commitment to seeing this event to fruition. Last but by no means least, thank you, the audience, for your indulgence. Journey home safely, and again, thank you.